That's as far as we got last class, so we're going to start there.
Is that a U or U?
U, 0, U.
Oh, no.
So we're going to actually graph this now. Okay, so every pi over 2, you're going to have an asymptote. And then we're going to graph these 3 points. So each line is a pi over 4, so negative pi over 4, negative 1 would be here, 0, 0, and then pi over 4, 1 would be here. And because this has asymptotes, it's going to go off towards those asymptotes. And this is going to be a bunch of mini cubic functions. And then the pattern repeats itself. So at every pi, it's going to be at 0. And then to the right, it's going to go up. To the left, it's going to go down. Yes, so they're all just the same. You're just repeating the same thing over and over again. So that's why it's periodic, because it repeats itself, but it's not sinusoidal because it doesn't do that. What's the amplitude? None, because it doesn't have an amplitude. None, NA does not exist, whatever you want to put there. So every time you see that, none, it will change, the number in front will change, and then you'll want to put a number there, but that's not right. The period for this one, if we're looking that it goes between negative pi over 2 and pi over 2, that's really pi. So when we're finding the period for tangent, we're using pi over v now instead of 2 pi over v. Our domain of this is going to be everything except our asymptotes, so I'm going to write that a little weird. X does not equal our asymptotes. Our asymptotes are at every pi over 2. So that's pi over 2 plus pi k. So at every pi over 2, but adding the pi. Because every pi over 2 would be like pi over 2, pi, and the in-betweens, and we don't want those. The range is what? All numbers. As we keep doing some of these, the x and y intercepts are going to get kind of difficult to figure out, but we'll cross those bridges when we get to them. These are simple because they haven't moved. They're at every multiple of pi. So I'm going to write pi k comma 0. So at every pi value there are, it would have an x-intercept. In this case, our y-intercept would be at 0, 0. Your asymptotes and your domain kind of go together because wherever it doesn't equal, that's where your asymptotes are. That should have been a k instead. So x equals pi over 2 plus pi k. Once we get down to it and have done the majority of these, really you need to be able to figure out your amplitude, your period, your asymptotes, your midline, but tangent doesn't have one. You can write that if you would like. Your phase shift, so that's your horizontal shift, and your vertical shift. we won't really be looking at domain and range, x and y intercepts. It's just good to kind of see. Questions on any of the characteristics? So to practice tangent, I'm going to do 2 of these with you, and then I'll let you do the other 2. Let's do 13 and 14. For 13, notice that these don't ask what the amplitude is because the answer would be none. What is the period of this if we're using pi over b? Pi over 2. So if you look back at our original, our period was pi and it was at every multiple of pi over 2. But if our period is pi over 2, that means the entire function of tangent needs to fit between 0 and pi over 2, and then repeat itself again every pi over 2. So our asymptotes are going to be at every multiple of pi over 2, not just pi over 2, 3 pi over 2, things like that, the odd ones, I guess. So it's been horizontally compressed. And then normally we start in the middle and we go up 1 and down 1. But it's been stretched by 5/2. So we're still going to start in the middle of each of these. And there'll be a lot more since it's been compressed. To the right, you're now going to go up to 2.5 instead of 1. And on the left, you're going to go down to 2.5 instead of -1. And it's just going to repeat itself for all of these periods.
Can you say that again?
Which part?
How you're doing the graph. I got
This-
the asymptotes with
The 5/2, it's being stretched to that number, up and down. So I'm going up to 2.5 and down to 2.5.
okay. Are the points on the asymptotes or no?
No. They should be close to it, but
Oh, okay. So it really doesn't like matter there?
no, as long as they're in the middle.
Oh.
Because if you were to do the table for this one, you would find that your pi over 4s became pi over 8, so they're really, really small in between the lines. Other questions on that one? We're going to do 14. Now that one I did do a table because of this period change. Because we end up with pi over 2/3, so 3 pi over 2. Which really means I'm going to have 3 pi over 4 positive and 3 pi over 4 negative of asymptotes. That was the speaker. No, And then to find the others, I'm just going to count that pattern. So in between, there's 6. So if I count another 6, another asymptote would follow. I will go back into the table here in a second, but you could do this one without. If you're thinking about it like this. So in the middle, it's still going to start at 0, 0. But now it's been vertically stretched to 3. So to the right, it's going to go off to 3. But it's not like right next to it. This is why I use the table. So I'm going to do this over here. So I'm using those values that we just wrote in that table. Negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. And then undefined, negative 1, 0, 1, undefined. And then we're applying both of these to the table. So multiplying the y's by 3, the reciprocal of 2/3 to x. So 3/2 to x, 3 to y. So it messes with our table, our original function a little bit. Not really our asymptotes, because this becomes negative 3 pi over 4. So if you weren't sure as to where those two numbers came from at the beginning when we split it, it really came from the table. Negative 3 pi over 8, 0, 3 pi over 8, and 3 pi over 4. Your y's would become negative 3, 0, 3, and undefined. So the 3 pi over 8 and the negative 3 pi over 8, that's where it gets a little messy. Because that's, I don't remember what that number was exactly. But it's less than 1/2. But more than 1/4. So when you graph it, it would be somewhere in between here. And then somewhere in between here. And then you would just repeat that. So this point would still be in the middle. And then go over past the first line, in between the next two, somewhere in the middle. Go back one line, somewhere in the middle of these two. And then the same thing for this one. So when your period changes and it's been stretched, you don't have to draw as many. But when it's compressed, you draw a lot more. So remember that you can use the table if you would like. You don't have to. But I want you to try 11 and 12. And then I'm hoping that we'll get done in the next 5 to 8 minutes. That way we can go over it before the bell rings. The answers to 9 and 10. Okay.
I thought
Sorry, I'm on the wrong page.
Oh my gosh.
11 and 12. That's the 2 we're on. Okay.
I got it.
So for 11, your period did not change, so it should have been exactly where it started at all of your multiples of pi over 2. And then the only thing that changed was that it stretched. So instead of going from -1 to 1, it's now at -4 to 4. For 12, 2 things happened. It was horizontally stretched by 2. So if it's now at 2 pi, really just bring that out. So pi was at -pi over 2 and pi over 2. 2 pi would have to be double that. And then it was reflected, so it has to face the other way. Make sure your arrows are facing the other way. If you wanted to know specifically where those points were, you could either use your table. I think what I did was, since it goes over 1 and up 1 usually, I multiply that by 2. Since it doubled. But you would see that in your table as well. So tomorrow we're going to start phase shifts. Some of these can be done without the table, but you really have to think about in your mind it's being stretched or it's being compressed and it's being shifted all at the same time. And then some I will do the table, but I'm going to try and only use it if you absolutely have to. That's it.